Here's the notes for section 8.4. It's called a match pair test. I probably even should have specified a match pair t-test. Let's talk about really quick what paired data is and where it's used in real life. Paired data samples draw conclusions about the differences. So circle differences, so how much different the data is paired. A common example is a before and after. So if you compared a student's pre-test with their post-test, you would subtract how much better they got. In psychological sciences, a lot of times identical twins are studied, and you can read the rest. So just keep in mind, though, again, you deal with the differences. So here's an example problem. A psychologist developed a series of exercises to help students, mentally retarded children. So in an experiment, a random sample of 10-year-old students with an IQ below 80 was selected. An IQ test was given to these students before they spent 2 years in the program, and an IQ test to the same students after the program. So hopefully you can see why this would be paired data. You want to compare each student with their self to see how much they improved by being in the program. So if you think of on what basis can you pair the IQ scores, that would be each student before and after. If there are 20 students in the sample, how many data pairs would you have? Well, there'd be 20 data pairs, and again, you would take the differences, the before and after. So let's look at how you do. It's very similar to a t-test. This is really hard to read right here, so I rewrote it. So you might be wondering what this is. This is the average, the sample average of the differences. So up here we had, let's say we had a student with a 70 IQ, and then after that program they went to 75, so their difference is at +5. Does that make sense? So you would enter all the differences into a column, and that's where this number comes from. I totally skipped over how to write the null hypothesis. So just try to think about why this is a null hypothesis. The average difference equals 0. If the true difference is 0, think that really means they didn't change. So if this kid's stayed to 70, their difference would be 0. So that's going to always be your null hypothesis, and we'll talk on the next page as far as when you do a greater than or a less than. And again, we're not really even going to do this by hand. What you do in your calculator is you just do a t-test in your calculator, but you enter the differences only in a list. And then it's the same thing that you've been doing. All right, sometimes the best way to understand is looking at an example problem. So I'm going to summarize what's going on here. These are patients getting ready to have a heart surgery, so obviously they have some anxiety about surgery. So what these scores are, their anxiety level, so the higher it is, the more anxiety they have before counseling. Then they receive some counseling. All right, so you can see Jan looks like her stress level went down. But do you see which way they subtracted? That's recorded as a positive. Tom stayed exactly the same, so counseling didn't see to help him. And then let's look down here at Barbara. Her anxiety level went from a 115 to 117, so she actually, has worse anxiety, let's call that. So again, you can choose which direction, but it made sense, I feel like, to do B minus A. So think of what kind of numbers do we want to test the claim. Can we conclude the counseling sessions reduces anxiety? I put a star by all people whose anxiety was reduced because of counseling. So do you see why I have the stars by these people? And those are positives. So that's what helps you write your hypothesis. So I already have the null hypothesis, and having a positive answer here is what we're looking for. So I'm going to write the average is greater than 0. And I'm going to enter these numbers into it. So numbers have been entered. Notice you do want to put the -2 in your list. So now to run the test, stat test, a t-test, I want it to use data, and I have it in list 1. All right, so there's our null hypothesis, 0, list 1, and greater than, so greater than, and here we go. All right, our t-value is very high, 4.36. P-value is very low. So we're going to reject the null and say, do we conclude that counseling sessions reduce anxiety? Yes, counseling reduces the true mean anxiety levels or something. If you're not here in class today, you're going to skip this because I have this up on my active board, and then the assignment is just the next few pages. 4 problems total.